Hello everyone. Today in this session, I'm going to do the solution for tutorial 3. Okay, so the solution for tutorial 3 has already been uploaded on Spectrum. So we will go through the question from the beginning, 3.1, 3.6, 3.7. But what I'm going to do is I'm going to rearrange the question according to the topic. If you can, I can bring you here. Okay, so let's look at 3.1. So what I'm doing is I'm just grouping them into set A, 3.1, 3.11, 3.21, and 3.35 because it's all related. Okay, so it's easier for me to solve it this way. So let's look at 3.1. The question, let X be the maximum of the number of heads obtained when Carlos and Michael each flip a fair coin twice. Okay. A. Describe the underlying space of this random experiment and specify the probabilities of its elementary events. B. Show the mapping from S to Sx. And C. Find the probabilities of the various values of X. Okay, so here is the sample space. Okay, if you look at Carlos, he's flipping the coin twice, so the number of heads can be 0, 1, and 2. Same goes for Michael. He's also doing the same thing, and he also have the same possible outcome. Okay, so when you look at the flipping of a coin twice and the number of heads that you can get, if we write all the outcomes, as you can see here, this is 2 heads, right? And this is 1 head, and 0 head. Okay, so the probability for 2 heads is 1 over 4. For 1 head is 1 over 4 plus 1 over 4, 1 over 2. And for 2 so 2 heads is 1 over 4. This is 0 heads. So what goes in is the combination of these two outcomes, okay, whereby you have 0 for Carlos and 0 for Michael. Okay, so the probability is 1 over 6 because 1 over 4 for Michael times 1 over 4 for Carlos. Same goes for 1 head, the probability is 1 over 2, right? And same goes for Michael, the probability is 1 over 4. So 1 over 2 times 1 over 4, this is 1 over 8. Okay, so this is how you read. This is the outcome 0, 0, and this is the probability for that combination. Okay, so as X is the maximum of the number of heads, right? X is the maximum of the number of heads. That's the question given, and you were asked to find the distribution for this. So these are all the outcome, right? 0, 0, 1, 0. This is 2, 0, right? So Carlos and Michael. So when we have this outcome, what is the maximum? 0, 0, the maximum is 0. 1, 0, the maximum is 1. 2, 0, the maximum is 2. So we tabulate, we fill up this boxes according to what are the combination that we get in this. For example, here, Michael is 2, Carlos is 0, so the maximum is 2. Okay, so now we need to find the probability distribution for X. Okay, now X is the maximum of heads, so we have X, and we want to find the probability of that X. So again, you see you have 0, 1, and 2. That's all the outcome for you. Okay, for the probability of X taking 0, so you see where we get this outcome just once, and the probability is given by 1 over 16, right? So the probability of 1, you see 1, 2, 3. 3 outcome. 1 over 8 plus 1 over 8 plus 2 over 8. 1, 2, 3, 4. 4 over 8. Okay. And the last one is the outcome 2. 2 you have 1 over 16 plus 1 over 8 plus 1 over 16. 1 over 8 and again 1 over 16. Adding them all up give me 7 over 16. Okay. So you should check your distribution if it's complete or not by adding up all the possible outcomes here. Okay, so 1 plus 4 is 8. 5. 5 plus, this is 1 over 16. This is 8 over 16. Right, so you have 1 plus 8, 9 plus 7, 16 over 16. Right, so all is 1, so it should be good. Okay, let's Okay, so let's look at the next question, which is 3.6. So 3.6 is this. Oh, sorry, 3.11. Okay, so I'm following this susunan. Okay, 3.11. So 3.11, A, let X be the maximum of the coin tosses in problem 3.1. Okay, so we referring to this. A, compare the PMF of X with the PMF of Y. So X is the maximum of the two coins. Y is the number of heads in two tosses of a fair coin. Explain the difference. And B, suppose that Carlos uses a coin with the probability of heads. So it's not a fair coin. Okay, now head has a, a higher a higher probability of occurring when you flip it. Okay, so 3 out of 4 chance is going to be a head. So you asked to find the PMF of X. So this one, Carlos is the only one that has this coin, this special coin. But Michael has the same old coin. So let's look at how does this X changes. Okay, so this is 3.11. This is our PMF for X. X is the maximum number of heads in two coin throws by two people. Okay, by Carlos and Michael. Okay, so from the solution we did, this is what we found. Okay, so now Y is the this is the distribution of Y. Y is the flipping of a coin twice. Okay, so this one is the original where we have just now Y either 0, 1, and 2, and the probability of Y 1 over 4, 1 over 2, and 1 over 4. We've done this before. We flip a coin twice. What is the number of heads? This is for Y. Okay, so this is different. So this is flipping of a coin twice by two people and then finding the maximum. So there is a difference in the probability distribution. Alright, so let's look at B. We name X prime as the Carlos uses a bias coin. Okay, so when we look at bias coin, we say that the probability of head is 3 over 4 and the probability of tail is 1 over 4, right? So what happens is that we have a different distribution for Carlos. Okay, so if X prime is the number of head, let's do this. Okay, number of heads for Carlos. Okay, so X1, 2, so PX 0 is become no heads, so it's 3 over 4, so 1 over 4, so 1 over 16, right? This one becomes 2 over 16, no, 2, 3 over 16 times 2, 6, right? And okay, and for 2 heads, so 3 over 4 times 3 over 4, you have 9 over 16. Okay, so this is the value given here. So how you read this? A 0 head for Carlos, the probability is 1 over 16. 1 head, 6 over 16. Probability of 2 heads is 9 over 16. Okay, so now X prime is the maximum of the two number of heads in two coin throws by two people. One is Carlos and one Michael, where Carlos is using a bias coin. So that is X prime. So let's look at here. Again, you have the same maximum number of heads, okay? But the probability is different. Okay, for 0, it is 1 over 16 times 1 over 4. Okay, so 1 over 64. For 1, so you have here 1 over 4 times 6 over 16. Okay, and then plus this one, 1 over 16 times 1 over 2 plus this. So you have 1, 2, 3, 3 occurrence. 1, 2, 3. And the probability is, you can see here, 1 over 16 times 1 over 2. Okay, and for this, 6 over 16 times 1 over 2 and again 6 over 16 times 1 over 4. Okay, so this is 20 over 24. For x prime equals to 2, so you have this with the respective probabilities. So you solve this, you get 43 over 64. Okay, so outcome is for x prime 0, 1, and 2, and the probability distribution has changed, whereby you have 1 over 64, right? For 1 is 20 over 64, and the other one is 43 over. Add them up, you should get 1, okay? So if you can draw it in terms of this, the PMF of x prime to be as follows, okay? So let's look at the next question. Okay, so the next question is 3.21. In problem 3.11, just now, compare the expectation of y. So y is the PMF for the number of heads in 2 tosses of a fair coin, and E of x is the maximum of the coin tosses by these two guys, Carlos and Michael, but they are using a fair coin. Okay, so you asked to calculate what is the expectation. Okay, so to find the expectation, okay, E of y is where you have to sum up all the values of y with the probability of y taking that value, right? So let's look at y. This is the PMF of y. Okay, so this is my value for my y. Okay, so 0 times 1 over 4 plus 1 times 1 over 2 plus 2 times 1 over 4, okay, gives me 1. What about the E of x, expectation of x? X, you get it from the problem 3.1 just now. Okay, so this is what we obtain. So again, the expectation is 0 times 1 over 16 plus 1 times 8 over 16 plus 2 times 7 over 16, giving me 22 over 16. Okay, for the variance, okay, you just have this as the formula. Okay, so we have E of y just now. We need to square that later, but expectation of the y squared. Okay, so this is how we use it. Okay, you have the y squared multiplied with the probability of y taking the value y. Okay, not the value of y squared, but y. So be careful when you use the formula. And this is the answer. So the variance, you just plug in 3 over 2 minus the 1 and then you square it. Similarly, for the variance of x, you do the same thing and you get this as your solution. Okay, and you can compare. We find that the variance of y is bigger than the variance of x.